Hello, honors higher algebra students. This is Mr. Johnson, and this is the second lesson in logarithms. And what we're going to talk about during this lesson is a variety of properties for logarithms that will help us to solve logarithms. Okay, so we have talked about this in our previous lesson a little bit in terms of what a logarithm would fall between. You know, we don't know what log base 2 of 9 is by hand, but we certainly could figure this out by estimation. We could figure out kind of something that would be between. So for example, you could think of this as x and 2 to the x is equal to 9. So if we were to convert this into exponential form, so we know that that 2 to the third is 8. I'll write that down. So 2 to the third is 8, and we know that 2 to the fourth is 16. And so we know that this value is in between 3 and 4. And we could kind of estimate it from there. With this other one, we have log base 4 of 14. So again, kind of the same thing. We could say, well, we know that 4 to the first is 4. We know that 4 to the second is 16. So we know this is between 1 and 2, probably closer to 2. In order to do this exactly, we would need to use our calculator. And we've already talked about this again in the previous lesson. We talked about the change of base. For example, we have the common base log base 10 of 9 divided by log base 10 of 2. Remember that in your calculator, if you have the newer calculator, you can just simply type this expression in and you'll get your value. But I'm going to go ahead and pause and I'll type this in and give you the answer. All right, so when I type this in for the first one, I get 3.1699 and it keeps on going. And then for the second one, I get 1.9037. And again, we can review that later as well, but that's our calculator operations. And again, we covered that in the previous lesson, and we'll touch on it again. Okay, let's go over some properties. So there's a couple examples here on the left side. We actually have talked about the first two. We mentioned that if you have log of a base that's a positive number, for instance, in this example, a base of 8, and you have an argument of 1, then your answer will be 0. And we converted this into exponential form. So we said, okay, 8 to what power? Maybe I'll use a question mark. So 8 to what power is equal to 1? And the only power that would make that 1 is going to be 0. Same thing here. 3 to what power is 1? That's going to be 0. So you can remember this property. It's a property that will come up that if you have, log base 100 of 1, it's 0. Another property that's important to know is that if the base and the argument is the same, then the logarithm will be equal to 1. And this is pretty easy to see because you have 2 to what power is equal to 2, and therefore it has to be 1. Or 5 to what power is 5, that has to be 1. So log base 102 of 102 is 1. Okay, so what are the general rules? Well, again, what I mentioned was that if you have a base a, for example, and you have the argument of 1, then that logarithm will be equal to 0. And if the base and the argument are the same, the logarithm is equal to 1. So those are good properties to keep in mind. Okay, let's use those properties to do a little bit of solving here. The notation looks a little funny on these slides, so I just want to clarify that this is log base 2, and the argument is 2 to the power of x, like that. So we want to figure out what this is. Now, again, keep in mind that we have a base of 2, and we say, okay, what power is it if it's equal to 2 to the x? Well, we can see that those powers then must be the same. So this actually simplifies to x. Again, I'm going to rewrite this one because the notation is a little bit strange. So this is an argument of 5 to the power of 3. And so again, we could think of this as 5 to what power is equal to 5 to the third. And you can see that those powers have to be the same. So we have to have a value of 3 here. Now this is a general property. And again, I'm going to write it just to make sure the notation sticks with everybody. So you have a base of a, and then your argument is a to the power of x. And that is actually an interesting an interesting property where you can take the power of the argument and you can bring it to the front of the logarithm. So again, I'll show you another example of this. So you can take that that power of the argument, it has to be a power of the argument. You could take it to the front of the logarithm, and then we know, because of the previous page, that log with a base of a and an argument of a is 1. Therefore, we get x. So let me give you another couple examples on this one because it's a little bit more complicated. So what if you had like log base 2 of 2 to the 4th power? Well, we can bring the 4th power to the front of the logarithm, and you have log base 2 of 2, and therefore you get a value of 4 because log base 2 of 2 is 1. Notice I didn't put parentheses around the 2. You absolutely could. What I usually put parentheses around the argument when there's more than just a single thing there, okay? So that's why I didn't put parentheses around it when it was just 2. But if it's 2 to the 4th, I put parentheses to kind of notate what the value is. Let's say you have log base 3 of 3 to the negative 2nd. That's the same thing as negative 2 times log base 3 of 3. And that is equal to negative 2 because log base 3 of 3 is 1. So you can start to see this pattern of this particular form. So when the base and the argument have kind of the same value, if that exponent, as you can see here, this exponent of 4, the exponent of negative 2, you can bring that to the front, and then you can evaluate the logarithm from there. Okay, let's move on to the next one. So this one, again, the notation is really poor, so I apologize. So this is 7 to the power. I'm going to put the power in parentheses so it's really obvious. So it's the power of log base 7 of x. So this is a bit strange because now the logarithm is actually in the power. I'm gonna show you kind of why this works. So let's say we don't know what this is. All right, so we have it equal to some question. Well, right now this is actually an exponential form. Even though there's a logarithm in there, notice how it has a base of 7 and an exponent with a variable. Now the exponent does have a logarithm in it, but I'm going to turn this into logarithmic form. So remember, if I turn this into logarithmic form, I'll do this over on the side. If I turn it into logarithmic form, my base is 7. Okay, so I have log base 7. My question mark is my argument. So I'm going to put my question mark there. And remember how a logarithm is equal to an exponent. So my exponent is what it's equal to, which the exponent is actually log base 7 of x. Now, if you notice, visually, this is pretty obvious that the question, whoops, that's not what I want to do, sorry. The question right here is what x is. So therefore, this particular problem is equal to x. Okay, let's look at a numeric example. So I'm going to rewrite this. This is 10 to the power of log base 10 of 3. Okay, so this is exponential form. Remember, even though there's a logarithm in it, I'm going to turn it into logarithmic form. I have log, remember the base is 10, that's right here. So I have log base 10. The exponent is what it's equal to. I'm trying to figure out what this whole thing is equal to. So my argument is my question mark, and it equals log base 10 of 3. So you can see that hopefully the question mark is 3. So this is equal to 3. Let me give you another example of this one. Actually, hold on, let's do this first. Let's go over here and do the general one. Okay, so this is a to the power of log base a of x. Remember, exponentials and logarithms are sort of undoing properties. And so this property gives an output of x. And it's because of those patterns that we saw over here as we rewrite them. So you don't have to rewrite them like I have right here. You can just go with the property. Again, I'm trying to have you see that there are these, I guess you could call them shortcuts to all of this. So if you had, let's say, 3 to the power of log base 3 of 4, that's going to give you 4. If you had 4 to the power of log base 5 of 2, that's going to be a problem because notice how the base of 4 is not the same as the base of the logarithm. And so there's not really much you could do with this one if you didn't have a calculator available. Okay, let's say you had, let's let's see, let's do like 10 to the power of log of 3. Remember, if you have log of 3, that automatically means it's a common log, which is base 10. So since the bases are the same, then you get 3. Okay, so let's try a couple of these. Again, I apologize, the notation is really poor. So this is 12 to the power of log base 12 of x. Well, that's one of our properties. That's going to be x. Log base 6 of 1, we know that's 0. Remember, that's one of the properties we discussed. Log base 4 of 4, that's 1, another property we discussed. Remember, this one is log base 3 of 3 to the x. Remember how we can bring this to the front. So we have x log base 3 of 3, and so this gives us x. So there you go. You have just a few more examples that pertain to those properties that we just explored. Okay, let's try a few more. So we have 3 to the power of log base 3 of 6. That gives us 6. All right, this one's a little interesting. Let's simplify it. So we have log base 8 of 8 to the 1/4 power, right? And we can rewrite that as 1/4 of my logarithm base 8 of 8. And that gives me then 1/4 based on our properties. Log base 8 of 8 is 1. Okay, let's be creative with number 2 here. Sorry, I kind of went out of order. I didn't realize I was doing that. So this is log base 4. So I'm trying to think of a way to make this base 4. So remember, 1/16 is 4 to the negative second power. And I can bring the negative 2 down and get log base 4 of 4. And therefore, I get an answer of negative 2. So again, we're using all these properties here. You have to be pretty creative. Okay, this one's a little bit tricky because, if I was to take, don't write this down, but if I was to take my base and make it 3 to the third power, that's going to be a little complicated because I really don't have a property that pertains to that right now. So we really can't manipulate the base. We sort of need to leave this base as 27. But is there a way for us to make 3 a base of 27? And again, you have to be kind of creative here. Remember, 3 squared is 9 and 3 cubed is 27. So what we could do is take the third root of 27, because remember, the third root of 27 is going to be 3. And therefore, we can bring the 1/3 down and get log base 27 of 27, and that gives me 1/3. So again, you got to wiggle it around a little bit. Okay, a few more properties. This is a way of combining logarithms. So the first one is the product property. So if you have a log with a base of b and a log with the same base b, and you add them, you can simplify it into one logarithm where you multiply the arguments. So for example, if I have log base 2 of 5 plus log base 2 of 4, that gives me log base 2 of 20 because I multiply 4 and 5. The quotient rule means that you have kind of the same thing except it's subtraction, and therefore you divide the arguments. If you're really in tune to why this is working, you can remember back to exponentials, and these are properties of exponentials from our last unit. But anyway, so this is, let's say, log base 3 of 2, and we subtract. Actually, you know what? Let me make this a better number. So let's do like log base 3 of 10 minus log base 3 of 5. That's going to give you log base 3 of 2 because 10 divided by 5 is 2. The power rule is one that I already discussed in the previous examples because it lends itself really well to those simplifications. So remember, that's log base 2 of like, let's say it was 5 to the third. That's the same thing as 3 times log base 2 of 5, which I can't really do much with that, but at least I can rewrite it if I need to by bringing that power down. The last property is just saying that if you have a log with a base of b and a log base of b, the arguments must be the same. So if you have, I don't even know, let's say it was an unknown. Let's do log base 2 of 4 equal to log base 2 of x. Well, that way we can see really clearly that x must be equal to 4. Okay, so let's use some properties to try to simplify these. So remember, with this product property, we have log base 4 in both cases. So then what we do to combine is we take 32 and we multiply by 2. So we get log base 4 of 64. And I could write that, or we could write that as log base 4 of 4 to the third. And we can bring our 3 down. And we have log base 4 of 4, which is 1, so we get a value of 3 there. So in other words, if you were to type this into your calculator, you would get 3. You can check that if you'd like. For our next one, we have log base 3 in both cases. That's good. And this time we're going to take, because of subtraction, we're going to take 36 divided by 4. So we have log base 3 of 9. And remember, 9 is the same thing as 3 squared. So we get 2 times log base 3 of 3. Log base 3 of 3 is 1, so we get 2. So again, if you take this guy, type it into your calculator, you can double check that you get 2. Okay, so then for our last one, we can't really do much as it's written because, well, I suppose we could do a little bit of stuff, but one of the things we could do, I'm trying to help you with this one property, is that we could take that 3 and make it the power of 4. So I'm actually going kind of backwards to what we've been doing. That gives me log base 8 of 64. And 64 is the same thing as 8 squared, which is 2 times log base 8 of 8. I'm kind of going backwards. This is not the only way to do it, by the way. And I get 2. So again, if you typed it in, you would get a value of 2. All right, let's use a few more of these. These are a little bit more complicated. So we have log with a base of, base of 3 halves down there. And our argument is 8 over 27. I'd like, I'd like these two to be the same. So I'm going to make this argument 3 halves. However, I'm going to raise it because I want to make sure that it's the same as 8 over 27. So I'm going to raise it to the power of -3. In other words, 8 over 27 is equivalent, it's the same, as 3 halves to the -3rd. So I'm just rewriting it. I'm not changing the value of it. It's the same value. I'm just rewriting it because I want the base of the logarithm and the base of the argument to be the same. Okay, that's really important. Now it's all equal to 2x. Okay, remember on the left side of this, I can bring the 3 to the front, the -3 to the front, and I have log with a base of 3 halves of 3 halves. It's all equal to 2x. Notice that all of this is 1. Therefore, I get, I'll kind of come up here for a second, -3 equal to 2x, which means x is equal to -3 halves. Okay, for our next one, it looks kind of ugly because it has a lot of stuff there. Remember that both the bases are 9. And remember that property that says that if we have a log base 9 in this case, and it's equal to the log base 9 of something else, because the bases are the same, then the arguments must be equal. So we can set these two arguments equal and then solve. So let's subtract. So we have -6x, and then we'll add 3, so we get -12, and that means that x is +2. Okay, let's work on the left side of this next one. So the next one, we could look at combining these two with the product rule. So we have log base 5, and we're going to multiply the arguments. So we're going to multiply 2, and we're going to multiply x plus 5. So what we get is 2x plus 10, and that's equal to log base 5 of 6x. Okay, so since the bases are the same, just like in the previous problem, the arguments must be equal. So we have 2x plus 10, which is equal to 6x. And then we'll just balance. So we have -4x, and that equals -10. So x is equal to 10/4, which is equivalent to 5 halves. Okay, let's talk a little bit. I actually mentioned this in the previous lesson the day before, but remember how we could take the square root and we get the absolute value of x equal to 4. That means x is equal to plus or minus 4. We could take the fourth root. I'll raise it to the 1/4 power here. And in a similar way, because of that even power, we get the absolute value of x, and we get 3. Therefore, x is equal to positive or negative 3. Okay, so this is really properties of exponents or exponential equations as we solve like this. And we're using this exponent to simplify in order to solve for x. Okay, so let's talk about the idea of 2 to the x equal to negative 4. If you were to turn that into logarithmic form, you have log base 2 of negative 4 equals x. Remember, you are unable to find a value for which this equation is equal. These equations cannot be equal because there's nothing with x that you could plug in to get negative 4 if that base starts off as a positive value. So the argument of a logarithm cannot be negative. And again, we discussed that the day before. This is just a reminder of that. All right, let's take a look at a few of these with regard to the idea of not being able to have that negative argument or negative base. So with this first one, we have, if it's an exponential form, we have, this is logarithmic form, obviously. And in exponential form, we have x to the power of 2 equals 9. If we take the square root of both sides, we have the absolute value of x equal to 3, which would imply algebraically that we have positive or negative 3. Now, when we look at the original problem, we can't have a negative base. That is not allowed with logarithms. And so therefore, negative 3 is sort of the idea of this extraneous solution because it comes out of the answer algebraically. But x equal to 3 is going to be our formal solution because that does work. Now, the difference is that if you look at the next problem where we have x squared equal to 16, that's x to the 4th equal to 16. That would be a similar process. Remember, we're going to take this to the 1/4 power. And we get absolute value of x is equal to 2, which means x is equal to positive or negative 2. Both of these are answers. And the reason is that when you look at the original, if you have negative 2, you're squaring it, which makes it positive 4. And if you have positive 2, you're squaring it, which makes it positive 4. So you're not going to get a negative base or a negative argument. And so therefore, both would be possibilities. Okay, let's take a look at the last one. I'm going to use properties of logs to combine these two. So we have x minus 3 times x plus 5. And it's all equal to log base 7 of 9. So that gives me log base 7 of, I'm going to just distribute this out. So I have x squared plus 2x minus 15 equal to log base 7 of 9. Okay, well, our properties state that if the bases are the same in this type of situation, then the arguments are equal. Okay, we're going to set this equal to 0. So I have a quadratic equation that I'm going to solve by factoring. And in this case, I'll have x plus 6 and x minus 4 equal to 0. So that means that I have answers of x equal to negative 6 and x equal to positive 4. Now let's go and double check and make sure that these work. So if we were to take negative 6 and try it in this first one, we get negative 6 minus 3 is negative 9. That is not okay because that's a negative argument. So this is extraneous. Let's double check that 4 works. So if I plug in 4 here, I get an argument of 1, that's okay. Plug in 4 there, I get an argument of 9, that's okay. So 4 is an okay answer. The other one is not an okay answer based on our equation. All right, so your homework here is to do the worksheet for the second lesson in logarithms, which covers the properties of logarithms. And we'll go over more questions in our next class period. Thank you.